In this video, we're going to start learning our different types of tests that we're going to be using to figure out convergence or divergence of a series. So, previously, we've determined the convergence or divergence of several series by explicitly calculating the limit of the sequence of partial sums. But the problem with this is sometimes to do that, it's very difficult or it's impossible. So, we've developed tests to do this. Now, the first test that we're going to go over is the divergence test. But there are other tests like the integral test, and within the integral test, you have like a p-series, there's the comparison test, there's the alternating series test, there's the ratio and root test. So there's all these other tests that we have to answer the simple question, does this series converge or diverge? So let's begin with the divergence test. This should be one of the first tests that you always try to use because it's number one, it's easy, and number two, if you can demonstrate that the series diverges, you don't have to do anything else. So for a series from n equals 1 to infinity of a sub n to converge, the nth term of a sub n must satisfy the following. A sub n goes to 0 as n goes to infinity. Therefore, from the algebraic limit of properties for sequences, we have this. The limit as k goes to infinity of our sequence is going to equal the limit as k goes to infinity of sk minus sk minus 1. So it's the first term minus its previous term. We can distribute the limit. So we're going to distribute that limit to each one of these. And what happens is the limit as k goes to infinity of sk is going to equal s. And then the previous term is also going to be s, and s minus s equals 0. So if our series converges, the nth term goes to 0 as n gets larger and larger and larger, as n goes to infinity. All right? An important consequence of this fact is the following statement. So this is the most important part. If a sub n does not go to 0 as n goes to infinity. So this portion right here, the more terms you have, if they don't start to approach 0 as n gets larger and larger and larger, then we know our series will diverge. And this right here is known as the divergence test. So let's go ahead and let's write a formal definition, and then we're going to look at some examples. So here's our formal definition of the divergence test. If the limit as n goes to infinity of a sub n equals c, and c does not equal 0, or the limit as n goes to infinity of a sub n does not exist, then the series diverges. All right. So here's how this works. All right. First thing you're going to do is you're going to find a limit of the sequence. And if it equals some number, you want that number to be 0. If it is not 0, or if the limit does not exist, you automatically know this series diverges. And there's nothing else you need to do. All of our questions basically are going to be, does this series converge or diverge? If it converges, where? That's basically it. All right. So let's go ahead and let's look at some examples on how to do this. All right. For each of the following series, apply the divergence test. So here's our first series here. It's going to be from n equals 1 to infinity of n over 3n minus 1. All right. So this is how we approach this. First, since n over 3n minus 1 goes to 1/3, and 1/3 does not equal 0, by the divergence test, we can conclude that our series here diverges. Now, this is very all well and good, but the big question is, okay, how did I do this? All right. Remember, and I'm going to do this in a different color here. Do it in red. We need to take the limit as k goes to infinity of k over 3k minus 1. All right, and I just use k because that's what I chose. All right. Now, remember from the previous video about the degree of the numerator and the degree of the denominator and stuff like that. Since our degrees on the numerator and denominator are both the same, they're both the number 1. What ends up happening is, as k goes to infinity, this minus 1 means absolutely nothing. It's like saying you have $100 million minus 1. All right? That $1 you are not going to miss at all. All right? So as k gets larger and larger and larger, this will approach 1/3. And since 1/3 does not equal 0, we automatically know this series diverges. That's it. Then you move on to the next problem. The issue becomes, what if it does converge? Well, then you need another test. And that's where all the other stuff comes in. Let's look at another problem here. How about the summation n equals 1 to infinity of 1 over n cubed. This is a very special one. You'll see why in a second. All right. So once again, if we take the limit as n goes to infinity of 1 over n to the third, you basically have 1 divided by an enormous number, which is 0. So in this scenario, let me write this in red, because like I said, this one's very important. In this scenario, the divergence test is inconclusive. Now, what this means, I'm going to write it out here. Because our test for divergence is inconclusive. This does not imply that we have a convergent series. All right? So let me repeat this. Just because the divergence test turned out to be inconclusive, that does not imply that our series from n equals 1 to infinity of 1 over n cubed converges. All it means is this test was not a good enough test. It wasn't an appropriate test for us to use. All right? Later on, we're going to learn that 1 over n cubed actually converges, but you need a different test for it. So the test for divergence, it does one of two things. It either says, yes, this diverges, move on. Or it says, I don't have enough information to make a conclusion about this specific series. Please choose another test. Okay, let's try one more here. Let's do n equals 1 to infinity of e to the 1 over n squared. All right, so with this, once again, if we think about this, we're going to take the limit as n goes to infinity of e to the 1 over n squared. Now, when we go ahead, we substitute the infinity up there, we get 1 divided by infinity. Oops, sorry, I forgot my arrow. We get 1 divided by infinity, which is essentially 0, which means this is e to the 0, and that is equal to 1, which does not equal 0. So this series diverges.